Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I am with Nathan Stocks. Nathan is a engineer at GitHub and also course creator or teacher or...
Yeah, I call myself a Rust instructor.
Yes, but you're not just doing Rust too, but we'll get more into that because I want to hear more about kind of your background because Rust teaching is not your first foray into teaching, right? You did some other
That's
teaching
true.
first.
Yeah, that's true.
Yeah, so why don't you go ahead and kind of give us a quick introduction about, your background, who you are, and why we should, why you're here.
Sure. So I've been in industry 20 or 25 years, depending on what you count and how you count. Worked at several places. Right now I'm working at GitHub as a senior software engineer. I've been a manager off and on. I discovered that management is not really my thing. I like mentoring. And at one point I confused managing with mentoring. And anyway, finally figured that out. What other kind of history are we interested in here? Are you looking for like career history, programming history? Like, what do we think?
I think the most interesting part is when I started learning programming, it seemed like everybody who I was learning from was like, oh, when I was 10, my dad gave me a very old computer that's quite famous. And, I started learning programming by myself. And, I was doing assembly when I was 15. And, like they have a very extensive history with programming when sons are really young. And a lot of people not, they just don't, like for me, I didn't get an email address till I was in high school, I think. So I feel like I'm way behind the curve. But nowadays I feel like I'm in the right spot. So like it's to kind of hear about, how did you get started in this and why did you start doing this?
Sure. So my father brought home a Compaq Portable, it was a luggable computer. It was like, I don't know, 65 pounds or something. And you could like attach the keyboard over the 8-inch green screen in the front and lug it with a big handle. But that was my first computer. He brought it home when I was 4. I had an 8086 processor and I was hooked from then on. I didn't really get into programming until when I was 8 or 9. We got a 286 and it had QBasic. So I read through the whole QBasic book and played with that. And that was a really fun, month or two. And then I really didn't do anything again until junior high. They had one basic programming class. It was GW Basic. I went through that class. Didn't really learn anything. That was sort of a terrible class. That was all that was available in junior high. In high school, they had one Turbo Pascal class. I learned a lot more from the manuals, the Turbo Pascal manuals, than I did from the class because it wasn't a very intensive class. But that was fun. I felt like on the one hand, I was very privileged. I had access to computers my whole life, essentially. On the other hand, like I didn't really have, I had access to that one QBasic book and the QBasic program. And that was just about it, except for those couple classes until I got to university. We did have internet access, but I didn't realize you could access programming languages and things like that. I didn't discover open source until I was in my late teens, just going into college. And at that point, that's when it all really got going for me. So I went in to Brigham Young University and I went for a computer engineering major, which was electrical engineering with a computer science emphasis. So it was about 3/4 of the CS curriculum and then a whole bunch of circuits and electrical engineering and math and stuff like that I didn't end up using. I sort of wanted to go into a more hardware focused job, but life took me in a different direction. I ended up mostly I did full stack development for a long, long time. Did scripting languages on the back end, a lot of Python, a lot of TCL for a long time. I gave up on the front end about the 4th or 5th time. It betrayed me and became completely obsolete. And I had to relearn a completely new framework from scratch. And I just sort of disavowed front end and said, no, I'm a back end guy now. That's almost 10 years ago now. So yeah, I really wanted to be, I always thought growing up that I was going to be more of a low level guy. I always thought, C++. I never found a way to get into those in my career. On my own, I tried to dabble here and there, and I never really had a coworker I could rely on. I couldn't really find a community that would sort of like let me in. So my experience with C and C++ was mostly like I'd go dabble, and I'd spend 98% of my time trying to figure out why it compiled with no warnings, but didn't work. correctly and had spooky problems and then segfaulted. And I just couldn't quite figure it out. So I never really got into it. Around 2016 or 17, though, 2016, December 2016, I finally got to a point of my life where I just felt like, okay, it's time. Like I've done like all of this scripting languages. I've done umpteen other languages and dozens of different technologies. It's time to really sit down and master a systems programming language. And I already had the painful experiences with C and C++. So I did a survey. I took a month. I literally started on December 1st and I ended at the end of the month. And during the month, I just looked up and researched every systems programming language I could find. Anything that someone claimed was a systems programming language, I would go research. So I looked into Zig, I looked into D, I looked into Go, which by the way is not a systems programming language, but I looked into like everything I could find. I found over 50 different languages. That's a remarkable how many things are out there. But I really only considered 3 of them viable choices. There was the C and C++, naturally, and then Rust, which at the time was pretty new. It was just a year and a half after it went 1.0, and I'd never really heard about it. But I read, just my initial research got me hooked, and ever since then, I said, oh, Rust is the thing. It's going to be huge. I love it. It makes me happy to play with. And so I jumped into it. And so immediately in 2017, to force myself to learn it, I decided that I was going to teach it, because the way I had learned a lot of technologies before was I just teach it to my coworkers, but I couldn't find like an appropriate. I mean, there was a reason we didn't use systems programming languages at my workplace. We just didn't need them. We didn't have anything that was performance or efficiency critical. So I couldn't really do my teach the coworker thing to teach myself strategy. So instead, I decided to go teach it at a conference. So I just signed up for a local conference here at Utah to teach 2 sessions, actually. One session, just an intro to Rust, and another session of just like a show how to use it and like write a game from scratch. And then that sort of forced me like, okay, like now I've signed up. I've really got to learn this and teach it, or I'm going to look like an idiot at this conference. And it worked. Like I was able to learn it. The presentations went really well. I used the same concept and expanded on it and applied to OSCON back when O'Reilly still did in-person conferences, and went there, got good reviews. The O'Reilly publishers noticed me, asked me to come do some live events for them, some live trainings. And I did that. That sort of spun out to some Udemy courses. And I sort of fell into teaching Rust as a side effect of learning Rust. So that was sort of interesting. At the same time, like for the last 15 years, I've been trying to be an indie game developer. And there were sort of 3 periods. Starting about 2017, first I sort of tried to write a game engine, which is a huge, huge mistake, but interesting. Ended up going nowhere. So then I turned to Unity for a couple of years, got really frustrated with not having access to the source, and I chose their Python-like backend, which they then deprecated, and then I moved to their JavaScript-like backend, and then they said C# was going to be the thing, and like after 2 years of like constantly being switched out, not to mention hitting bugs in actual Unity itself that I couldn't get access to and fix, I just got frustrated, and then Unreal Engine 4 came out with they changed their licensing and said, oh, instead of paying us 50 grand up front, you can come and use sign our NDA and come use Unreal Engine 4. And after you've made money, you can give us a cut. So I switched over to Unreal Engine 4. I was super excited about it. Worked with that for a couple of years. Got as close as I've ever gotten to really making a game worth playing. Actually published a couple. I mean, in the sense that I got them to the store and you could buy them. They weren't really worth buying though. And I kept hitting all these showstopper bugs all over the place in Unreal Engine. Just, you'd be doing stuff and then just, it's gone. Segfault. Like the entire thing just collapses. And if you read their release notes, which are fantastic, by the way, amazing release notes. They take about 8 hours if you want to read them in depth. But like a third of the release notes are fixed a crash due to X, Y, or Z. And if you go and look and see like what actually caused the crash, most of those, they added an if statement that said, well, if this thing is null, then don't try to access it. And it's just bonkers stuff that wouldn't even be possible in Rust. So anyway, that time with Unreal Engine overlapped my beginning of learning and teaching Rust. And it just became obvious to me that the future of game engines is going to be in Rust. I mean, that's my prediction. And I wanted to hop on that train real early. So I just set Unreal Engine aside and said, okay, well, I'm just going to be involved in my learning, in my teaching, and get involved in the game engine ecosystem where I can. So I was a contributor to Amethyst when it was active, and then Bevy more recently. I've contributed to just little bits and pieces all over the game engine ecosystem where I sort of try something and notice a sharp edge and can help out. Nothing major. But yeah, anyway, and that led to eventually, sort of like you put all that together, it led to Rusty Engine, which is the game engine I made to support my latest course, my latest Rust course.
I just want to kind of go back over a little bit more because, yes, you also made courses. I think your first course was in Python.
Yeah, actually, I tried making a Python course. I mean, I successfully published it, but it doesn't really get used. It has I think it's been out for what, 7 years or something? It was a little too narrow. I focused it on testing with Python. So it's specifically about how to write and run unit tests with Python and use a test runner that I wrote, one of my first sort of successful open source project in the sense that a bunch of other people actually use it, called Green. And it's a Python test runner. It runs your regular unit test style tests, but it's got really nice output, lots of features, built-in integration with coverage, and it uses a bunch of sub processes to run the tests in parallel. So it can run a heck of a lot faster, especially on today's machines that have, 16 or 32 cores.
Okay, you use some kind of IPC to talk between them, right?
Yeah, just the bog standard Python mechanism for passing something back and forth between a sub process.
Yeah, I think I remember they have a separate library just for that. It's been a while since I looked at this because we were looking at ways you always look at ways to speed up Python. And I remember that they said, okay, you can do multi-processing. And then that was something we looked at. And then we looked at greenlets was another way to do it if you have IO intensive apps. And I think I remember somewhere where it said, if you need to speed up your Python app, consider C extensions. I think I remember that in the docs or something somewhere.
Yeah, which is, of course, no help if what you're trying to speed up is somebody else's Python code. So yeah, I just big hammer of just launching a bunch of sub processes, and some of them run some of the tests and some of them run some of the other tests.
Now, how did your first class go when you created the Python course?
Oh, I mean, it was about as unsuccessful as you could be. I didn't get any negative reviews. I just didn't get any students. I mean, it's been steady pretty much throughout its lifetime. I've got about 1 or 2 students a month, which is about as low as you can get but still have someone actually using it.
That's not too bad. I mean, I put out a course. I got like over 10, and for several months I didn't get any, and then all of a sudden last week I think I got one more student randomly, and he actually paid full price for it instead of actually using the coupon which we advertise all over. Maybe I did something wrong, but I'm
Yeah.
not going to complain.
Yeah, I don't know if anyone, unless they live somewhere not a first world country, could ever make a living on Udemy. I'm doing really well in numbers of students, but Udemy always has stuff on sale for like 90% off. And then if they come through Udemy, they keep something like, don't quote me on the numbers, but something like 70 or 80% of whatever they do end up paying. So I price my courses at, like, my intro course is $50, and Udemy regularly discounts it to like $9, and then they keep 7 of that. And so it's not really a way to make a living. So a good thing I didn't set out to do the courses to make money per se. So that was a good thing. The money I do make, I just turn around and I use it to pay for, like a pixel artist or a sound engineer to help me out with games. So that's the nice thing. For the money I do get, it sort of helps spur my other indie projects. So that's nice.
I think the only way you can really make money is you have to make it in bulk, right? So you have to have a following. So if you have 100,000 people buy it or 10,000 people buy it, then you'll actually make a decent amount.
Well, if you bring the people, then, or at least with Udemy, if you bring the people with your link, they only take 3% instead of 70 or 80 or whatever the percentages that they take. But like I mentioned to you when we were talking before we started recording, I am terrible at marketing. So I don't think that's ever going to happen for me.
The other thing too that you get, like you said, you can't get rich off of this. And people, if you make a book, like it's a incredible investment, right?
Hmm.
And but you don't make money directly from that. You make, I guess you call that tangent revenue, something like that, where it's like things on the side kind of start coming to you.
Yeah, yeah. And there's tangible benefits that aren't monetary, right? Like one of the things that I love about my courses is that it helps people learn Rust and they get excited about Rust. And for me, just getting someone excited and involved in Rust is hugely rewarding, just in and of itself. And then if they come and tell me about their experience, that's rewarding. If they come and participate in the ecosystem and I rub shoulders with them, that's rewarding. Like it's just sort of like a rising tide lifts all boats types of thing. Like this is a good thing for me in this ecosystem. It's just I like it.
Actually, I just had one quick question that came to my mind when you were talking about when you're looking at systems level programming languages. I do hear quite a bit about Zig. So Zig is quite popular in the Elixir community, and it's interesting. I'm curious about like what was your thoughts about Zig when you saw it? Because I'm trying to get somebody to come on the podcast to talk about Zig because I'd like to hear more about how does it compare. I was gonna say what I understand about Zig is that they always kind of the idea is that it's supposed to be a better C, which is kind of also similar to Rust to a certain extent. So that's why I'm trying to understand like what is Zig and why would I want to use it?
I really don't know. My evaluation was in December 2016. That's 6 years ago, 5 or 6 years ago now. And I really haven't circled back and looked at it since then.
And what was it that turned you off about Zig?
At the time, I don't know. I did nothing other than C, C++, and Rust met my criteria for quote unquote being viable. So in my mind, that means it's going to have a big community that you're going to be able to use it on all the platforms. It's going to be stable, that kind of a thing. Like the kind of programming language where you're going to be able to get a job programming in it in 10 years from now still.
Okay. That's actually one of the things I try not to look at. I look at programming languages as something I want to work in, but to say I'm going to find a job in this, that one, I don't know. I feel like
Yeah,
that could be
that,
tricky.
that might not be important. Depends.
Yeah, because I often see people online like, oh, I want to get a job. Should I learn, let's just say, Zig or some other, more obscure language? It's like, if you want to get a job, then maybe look at Java. I mean, there's Java everywhere, or JavaScript even.
Yeah, I definitely agree with you that you should never put your primary criteria as what can I get hired for. That's just the wrong way to go after things. Just like you shouldn't say like, well, what's going to make me the best money? That's what I'll choose for my career or my major going to college. That's a terrible, terrible way to make decisions. However, I do feel like it still has some value as one of a larger set of criteria.
Yeah, that's true. I mean, I just don't want to take it as like the only or the main one.
Oh, for sure. Yeah. Too many people do that, and that's a terrible idea.
Okay, so you taught Rust for the conference. Sounds like it went off pretty well. You were pretty excited, right?
Yeah, I got really good feedback. People seemed really excited, engaged during it. I got good review feedback. The staff, the conference staff, had good feedback for me as well.
Okay, and after that, you were like, maybe I can do this some more. Or kind of what was the thoughts after the feedback?
Part of it was encouragement from the O'Reilly editors. Part of it was I had zero money to bootstrap my indie game dev efforts. So if it did earn any money, that was a net positive. Part of it was, well, I knew that if I did it, that would force me to learn Rust, anything I covered in depth really thoroughly. And that has a really high value to me as well. So yeah, I consider myself an expert at beginner Rust. So I'm really, really, really good at the beginning concepts and teaching other people those concepts. As you progress up the stack, I've used the intermediate Rust a little less and the advanced stuff a lot less. So I consider myself a beginner at advanced Rust.
So I just want to be clear. After this course, was it immediately in your mind like, I want to teach more in Rust, but I want to do it with a game, or is it just I want to just keep doing the same thing, or kind of? I'm just trying to understand the process from I think you said OSCON to where we are now with the engine.
Sure. So after OSCON, O'Reilly encouraged me to teach the same content in some other formats. First at a follow-up conference, and then they wanted to do it live online. And so I did that. And then they said, this is great. They want more. Will you go further? And at the time, like I was fine being finished. I was like, okay, like I did this crash course in all these different ways. I did it live at conferences. I've done it live online, and then I packaged it up for Udemy. And I felt like, okay, that's a pretty good point. Like I can stop here. Like my intention is not to teach forever. But then they came back and really encouraged me, like, look at this review feedback again. And like, this is some of the most positive feedback we've ever gotten. And like, you're the guy who taught it. You sure you don't want to, why don't you just come and try like the next level course? Like, why don't you just, they basically talked me into like extending the O'Reilly version of my content into a longer course. And so then I took that extension, and that's become my second course on Udemy. And as part of that, I wanted to make a project that was interesting, so that when you get to the end of this course that I'm walking you through live, that I say, okay, now here's this project. Go do this project that's sort of going to use a bunch of all the skills that we just learned. And I wanted the project not to be boring. And my first project sort of was boring anyway. It was making a command line image processing program. So it would read in an image file, run it through some filters from some image library that we were importing, and then write back out the file. And so it's mostly command line argument handling and then gluing it together functions. And it was just boring. Like yeah, you could look at the output image file, but it just wasn't fun, right? I wanted something to be fun. Like there's too many books, there's too many courses that are like, okay, let's go over an HR account record. We need name and phone. It's just like the same boring stuff. Like the C++ books are, oh my gosh. When I was trying to get into C++, I read a couple C++ books, 2 or 3, and they were all like that. They're like, okay, let's take the most boring example in the world and let's just like beat it to death. And I wanted to do something that was like, okay, like let's do something that ends up with a result that's interesting. Like, oh, I actually want to poke this and see something, do something different. And, that aligned with all of my other sort of indie game dev tendencies. And so, well, maybe I could just make a game engine. So my first attempt was actually to make a game engine from scratch, but with a super limited scope. But game engines are like the hardest of everything in computer science all at once, right? Let's deal with everything in the world, make it really difficult. Oh, you want it to work on more than one operating system? Multiply that by 10 for every operating system that you have to deal with. So it was just like, I got a little something working, but it just wasn't worth using. At the time, I was contributing to Amethyst. So I was hoping that with the next release of Amethyst, another Rust game engine, I'd be able to maybe wrap that, I thought. That never really happened. The sort of Bevy sort of jumped onto the scene and became the next big Rust game engine, at least from my viewpoint. And it got to a point where I could wrap it. And so I did. And so Rusty Engine 2.0, I think, was my first one that wrapped Bevy. The first one that was actually viable and we could use it. I used that on one of my courses with O'Reilly. Worked out really well. Then 3.0 was a big ergonomics overhaul. And then 4.0, which I just released, refined the ergonomics a little bit more, got rid of the initialization macro, which is super nice not to have. And yeah, it all works. So Rusty 4.0 is wrapping Bevy 0.6, which was just released a couple weeks ago. And yeah, it seems to be working really well. So now I'm trying to finish up my pre-recorded project section of the course. Got to go refresh my crash course for Rust Edition 2021 because right now it's on Rust 2018. And then I feel like, okay, I'm at that point I can set my course activities aside and go focus my attention on actually trying to make some games again. So only this time I've got a trickle of revenue coming in from these courses. I can actually plunge that into these games. And so it's all very slow. I mean, some weeks I don't do anything. Some weeks I put in 12 hours. It's very sporadic because this is all moonlighting. I've got a day job, I've got a family, got other things going on in life. So it's just sort of a constant backgrounder.
But wrapping the engine, right? So what kind of things does Rusty Engine do when you wrap rather than just going straight to Bevy?
So the whole point of Rusty Engine is to hide or remove from view all of the game engine concepts that it can possibly get rid of. So in some way, it's just a dumbing down, right? So Bevy is a full general 3D game engine. Rusty Engine is a 2D game engine with a very small set of features. So what it does is Rusty Engine presents this very small, concise, intuitively understandable interface. You have a sprite. A sprite has an image. It has a 2D position. It has a float, an F32 rotation. It has an F32 scale. Really simple concepts. Does not take long to explain. Very intuitive for people. It doesn't use an ECS. I mean, the user of Rusty Engine can't see the ECS, can't see the entity component system that Bevy's using. Obviously, we need to use it behind the scenes, but the user doesn't have to see it. So they don't have to learn what's an entity, what's a component, what's a system, how do they fit together, how do I write queries, how do I deal with resources, how do I deal with mutable queries, immutable queries, just all of the concepts that you have to learn in order to use Bevy, a real or any real game engine. You don't have to learn. Yeah, it just takes all of that complexity out of it. I even went so far as to unify the coordinate system so that when you deal with text or you deal with sprites, it's the same coordinate systems. I do the translation under the hood. So you only have one coordinate system to worry about. You can't move the camera. You can't change the background color. Like there's a lot you can't do, right? You can only access everything in the engine through a single mutable reference to an engine state struct. So it's just very, very constrained. You can read the whole tutorial and the entire API documentation in probably less than an hour. There's just not that much surface. So it's really straightforward to just get into it, start it up. You don't even have to create or find or download images or sounds or fonts. Like it's included in an asset pack. So you can just use a sprite that already has a collider defined for it. And you can use a sound effect that's already there. You just pick one of the sound effects, play it. You can play looping music. It's already included. You can use one of the fonts that's already included. It's just, you don't have to think about all that stuff. And sort of continuing that theme, you don't even have to think about what the game is that you're trying to make, right? But the point of the game engine is to learn to use Rust. You're doing this while you learn to use Rust. So you take one of my pre-canned game scenarios and just run through it step by step. And I'll say, okay, like here's the scenario. You're trying to make a road race game. You're trying to make this little car and he's going down a road and he's avoiding obstacles. So first, do this, set up the player sprite like this and do that and do the other thing. And you just walk through it. And there's a couple of different scenario difficulty levels. There's the ones that walk you literally through every line of code. And they say, we're going to do this. Here's the code. We're going to do that. Here's the code. And then there's some medium ones that just sort of walk you through what you should do. Okay, you need to set up the stuff. You're going to need to use this part of the engine. Go figure it out. And then there's the advanced ones that are like, here's the scenario. Go make it work. And so, yeah, we simplified everything down and hidden everything. If you want to make a real go of it, and like once you hit the limitations of Rusty Engine, which won't take long, you can go over to Bevy, learn actual game engine concepts, and just move everything over and figure it out.
Okay, I'm just trying to think about that. I mean, the closest thing I can think about with this one is like on Pragpog, they have that book by Herbert, right? Have you actually seen or gone through that book?
Which book?
So it's Hands on Rust by Herbert Wolverson.
I don't think I've read that one, no.
You should check that one out. That one it's really similar to what you're trying to do. It's basically teaching people how to use Rust, but by building games using the game engine.
Which game engine is he? Did he make his own?
Yes, it's called Brackets.
Oh, interesting.
The name may have changed though, but he was actually a guest on the show. But people are really going crazy about it because it's, like I said, there's a lot of parallels where it's like you're trying to, teach people Rust through making games, and he's doing exactly the same thing. The difference is that you're putting a wrapper on a very popular game engine. For him, I think he made his thing from scratch, and it
Ah,
came
good for
from,
him.
yeah, he can do it. Anybody can do it, but if you got the time and everything else. But I think this is not his first game engine, right? He's been programming for quite some time. Anyways, yeah, like that one I said, like when I listen to this, it sounds very similar to that. And I guess this one definitely solves that itch or problem that you have, which is like, let's learn Rust, but use a more interesting example, which I mean, it's tricky,
Yeah,
right? Because if you make the example too complicated, then people will get lost on the example.
exactly.
And so, who's the target audience for this? Is it intermediate or is it really from beginners?
The target audience for all of my courses is existing professional software developers who already know at least one language really well and they want to learn Rust and they don't want to spend a long time doing it. My courses are focused on being very short, very, very content rich and dense. I have a lot of people who tell me that they have to pause or play my courses at slower speeds because I've just packed everything together so much. But it's really focused on, okay, I know how to program. I just don't know Rust. I want to learn Rust. And so my courses focus on this is the fastest way you could possibly learn Rust. But I'm not going to teach you any computer science fundamentals. Like you got to know how programming works in general. Like I'm not going to explain what a for loop is. I'm going to explain how it works in Rust.
Do you go over memory models and iterators?
I do. I go over iterators. I go over in the section about ownership. I go over about what it means on the stack and the heap for a move versus a copy and how things work. I dig into that. Yeah.
Okay. I always see that a lot. Like I'm familiar with the, like stack and heap and all this stuff because I had to take C++ as my first language in university. And so that stuff is pretty familiar to me. Like I'm surprised with how many people have to kind of talk about the memory model with this. But I guess it's because a lot of people their first language is like Python or JavaScript. And now I think about it over here in Hong Kong, like they don't really talk about that, which I find the most surprising. They kind of teach a lot of programming with Python and JavaScript for some reason, or that's been my understanding.
Yeah. I think that's pretty common over here now, too, from what I hear. I mean, college is a while back from now, but.
I mean, a long time ago they would teach you everything with gates, right?
Yeah. In my electrical engineering course, I literally had to start with the magnetics course where they taught us about magnetic fields. Then we went into the course, our transistor course, where we went over the physical transistors. And then we had a course that sort of built up transistors to gates to binary logic to assembly to C. That was all in one. That was a really interesting class to like go through that progression. And then, yeah.
How often do you actually use that stuff? I mean, I think it's good to have so that you understand what's going on, but how often do you actually use this kind of knowledge?
I don't know. I mean, it's not super often, but when it happens, like just knowing what binary works and binary means, and big endian and little endian just comes in handy at the weirdest times. I think the closer you work to hardware, the more this kind of stuff comes in handy. I would think that the people deep down in the Rust compiler dealing with LLVM and stuff like that have to think about it quite a bit, at least at some level, right? Certainly at the heap and cache level.
So when you're creating games, right, you have to think more about how can I make this faster or this kind of stuff, and you start thinking, okay, because I think you can actually access registers and stuff within Rust too. Am I wrong?
Well, you can do, let's see, the inline assembly isn't stable yet, but you can do it in nightly, I believe. So you could certainly do it through inline assembly. I don't know if you can do it through core at all. I've never really dealt with that level.
I'm pretty sure like you can get pretty specific. I don't think there's a lot that C can do that Rust cannot.
Oh, no. I mean, if you're willing to go with unstable, certainly you can do it all. Just a matter of how ergonomic it is.
And because you're just wrapping the Bevy engine, I think Bevy engine is actually production ready, right?
Well, it depends on your definition. I mean, if you want to click a button and have it spit out a package for distribution, no. If you want to make a working game, yes. If you want to use an editor, a graphical editor, no. I mean, what's your criteria? It can produce games. It functions. They've got some super innovative stuff in it already. The ECS in Bevy is amazing. They just rewrote the entire rendering subsystem on top of an updated. I can't remember off the top of my head, but like they've done some really really stellar work in Bevy already. But game engines are big, right? You can think of a game engine is on the scale of like the Adobe Creative Suite. Like there's just your commercial ones will have dozens of editors for dozens of things, right? It's all sorts of facilities and stuff that helps you actually with the creation. So Bevy doesn't have a lot of that. Like I said, there's no editor at all yet. It's all just you're dealing with source code. But still, like the fundamentals are there, right? The ECS and the rendering, the stuff they're working on are fundamental for a reason, right? If they're not there, you're not going to have a good experience no matter how much of the facilities you have. So they're working on what's important and they're going fast. I've been very impressed, very, very impressed. In fact, my biggest worry with Bevy is that Carter burns out. I hope he doesn't. I hope he's pacing himself. I've poked him a couple times and said, hey, please, like pace yourself. We want you to be in this for the long run because this is really turning out really well. Full disclosure, I mean, I contribute to Bevy. I'm a sponsor of Bevy, so I am biased. There are other Rust game engines out there and people doing great things, and I don't mean to take anything away from anybody else. This just happens to be where I'm involved.
Yeah, I tried to get him to come on to the podcast, and he was saying once he gets zero point 0.6 out, and he can probably do it. And then I think he's on a much needed vacation recently. From when I
Yeah,
tried
good.
to ping him again.
Good.
So, and I know he was like, "Oh, this is already 1 month late," and I think that was like many months ago. Like I think this .6 was a huge release. No,
It was immense. Yeah, rewriting all the rendering. That's quite a big task.
I'm also kind of curious too, like because we have quite a lot of engines out there. What is your opinion about? I mean, I heard about Unity. I heard a little bit about Unreal. Unreal, it sounded like you really enjoyed it, but it was just memory safety, which was causing some bugs for you.
Yeah, the biggest problem I had with Unreal is there was just me, and I'm not a C++ guy. And this is gospel according to me. They don't say this, but my interpretation of their attitude to my responses to bugs and my interaction on the forums and all this stuff was they seem to expect you to have a team of 7 C++ experts at your large enterprise that will iron out all of the bugs you encounter for you. So, for example, when they came out with Apple TV support around, 4.12 or something like that, it didn't work for me. And when I went to their support, they said, well, just do it all manually in Xcode then. That was the response. And I'm left here with, okay, one, the reason I'm using an engine is so I don't have to do everything manually. And two, I don't know Xcode. I don't know C++. I don't know what to do to hook all your C++ bits up and fix them manually to make it work for Apple TV, right? It's just like, I'm an indie dev. If you say it's supported and it doesn't work, I report it and they say, well, sorry, like go fix it yourself. Okay. Like that was just the kind of experiences I ran into over and over. Anytime I hit like a showstopper bug, I had two options. Hope they fixed it, which occasionally they did, but it would usually be in a full release, or fix it myself, which also I occasionally managed to do. I knew enough C++ to find that spot where there was the seg fault, go through the pain of making the change and recompiling from source for a freaking hour, running it again, and then my seg fault didn't happen. I contributed upstream, got it accepted. Yay! Like, had a couple positive experiences, well, semi-positive, positive in the end experiences, but there were too many things I couldn't fix. It just really turned me off, which was unfortunate because when it works, Unreal Engine is amazing. I mean, it's an established, really high-functioning game engine. It does a lot of cool things. I really had a good experience with the majority of my experiences with it. But in the end, I couldn't. I mean, someone more pragmatic, maybe I was just too idealistic. Someone more pragmatic may have just said, okay, well, like there's a dead end on Apple TV. So forget my plans for deploying to there. I'll go on to the next thing. Like now I'll make it work on Android or something. I would get rat-holed. Like, it's not working. It's supposed to work. They said it'd work. And I'd spend all my energy for a month on it, and then I'd get burnout and frustrated. And then I wouldn't want to work on it anymore. I wouldn't want to use the engine anymore for a month. And that kind of rat-holing and burning out just wasn't working for me.
Have you ever played with Godot?
Just a tiny, tiny bit. It looks super impressive. If it was where it was now, back when I was doing the commercial engines, I probably would have tried to switch to it at some point. But I didn't discover it until I was already well into the Rust scene, and I was not going to try to dive into Godot when I believed that Rust game engines were the future. Though I all respect to folks who use it. I mean, Carter, the creator of Bevy, he came from Godot to creating Bevy, so a lot of his experiences come from Godot.
Okay, would make some sense. But I know that they have like a GD native extension. A lot of people are using Rust to write their core logic, and then
I
they
heard
just
that.
connect it somehow. Yeah.
I've never done it myself, so I can't really comment on it. But I heard that it's really interesting. It reminds me of I saw a couple talks by actually it was your interview. I read or listened to your earlier interview with the Curl guy, and then I watched his talk that he gave yesterday or the day before as well about using Rust components and curl. That was super interesting. Rust is popping up all over the place nowadays.
Yeah, I feel like just within the last month, it's really exploded because a lot of people are talking about it. What I just saw recently, which is you're going to get this, right? You're going to get both sides of the coin where I saw that now you're starting to see malware written in Rust, which is going to be tricky to deal with because
Oh no.
with C and C++, right, you can find memory safety issues and then you can somehow deactivate it or whatever. Now with a memory or safe language, even more difficult to deal with malware, which is
I didn't never thought about the impact it would have on the quality of malware. How interesting.
yeah, definitely. It just kind of came from Reddit when I was flicking around. And I was like, geez, I never even thought about this one, like you said. And now it's kind of like the whole like privacy, encryption kind of thing. Yeah, okay, it's nice. I want my stuff encrypted. I want the government reading it. And it's like, well, these, not so good guys are also doing the same thing. So
Yeah, I have to wonder if they were really relying on bugs in the malware to resolve it very often. I can't think that was a major factor in a response to malware.
I'm not too sure, but it definitely does raise some concern because, yeah, I mean, if there is some memory safe issues that you can somehow exploit in order to take it off, I mean, if that's how they're exploiting things to begin with, I mean, you would figure you can somehow exploit them the same way. For at least some of them, I can't imagine that all of them are 100% safe. Otherwise, I don't know what to say. If these malware guys are so much better than everybody else at writing C, I can't imagine that.
Well, I would assume with direct access to the affected hardware, you've got a lot more strategies available to you than the malware folks did.
But in any case, the point is this, that it's spreading to new industries that nobody ever thought about.
True, very true. Yeah, I didn't realize when I started with Rust how popular it would become in the embedded systems areas. I've seen a lot of people talking about it in embedded systems.
You know what else is kind of funny? There's actually a library in Rust which is all about adult toys. It's just only library just for making adult toys,
Hmm,
which is very specific. I never really thought about that
that's way
this
out
would
there.
be
Yeah,
a
very niche.
an industry that it's like, okay, we need this in Rust. And it's like a whole group of people who just work on these functions. I don't know what's in it. I can imagine, but I don't know what's in it. But they have a whole name and everything. I forgot the name of the group, but there's a lot of niche stuff happening. A lot of people are talking about like ray tracing and things like that when it comes to Rust.
Anything super high performance, right? Yeah, one of the things I really have come to love about Rust that I didn't foresee was how it makes it so much nicer to collaborate with other people. Like, it's just so much nicer to work on a large Rust project with somebody else than, say, on a large Python project. I've worked on several large Python projects in the past, and even my own little green Python test runner that's written in Python. It's only like, I don't remember, 1,000 or 2,000 lines of code, somewhere on that order of magnitude. And I've got hundreds of tests on it. But even when I, the author, come back and touch it, I'm very tentative, because some things will break in mysterious ways because it's complicated enough and it's doing weird enough things that if I didn't think to write a test already, I might break something and not realize it. And it's really frustrating when that happens. But in Rust, I can do whatever I want. I'll try some crazy refactor and just completely change a type to something else different or refactor the whole way something works. And the compiler just, yelled at me, fix these 67 places. And then I just, rinse and, fix an error, run it again, fix an error, run it again. And by the time I get rid of the errors, it all works great. And it's crazy. What's crazy is I wrote a test runner in Python because I was so into testing, because testing was so necessary and I was so sold on it. In my Rust, I almost don't write any tests because almost everything I was testing for is handled by the compiler already. So there's just not a lot left for me to test. And it's so liberating to just be able to feel like, oh, I can just come and touch anything at any time and it'll tell me what I need to fix. Like, it won't let me push this out and just have some stupid error I didn't foresee. Oh yeah, I forgot I was using it in this other place. And since I changed this from, I don't know, from a string to a list of strings, like it completely went nuts. I mean, I've had that experience doing something like changing an argument for a function from a string to a list of strings and having it keep work in Python for a while because a string is also iterable and it started just going over characters instead of individual strings in this other place that I used it. 5 levels down in the call stack when it finally reached something else and blew up. It was, you had to trace it back to that change, and this doesn't happen in Rust.
I did see that they also have a way that you could add types in Python too. Have you seen that?
Yeah. In the recent versions of Pythons, you can optionally add type annotations. So that's really interesting. I have not used Python at my day job since 2017. So I haven't actually gone back and refactored my open source project to take advantage of any of that. Not to mention, I don't want to break it for the lower versions it still supports. But yeah, that was interesting. In fact, TypeScript, right, brought types into JavaScript in a pretty formal way, right? I mean, it's a different dialect. They went a lot further than Python did. It's interesting to see how scripting languages of various flavors sort of try to circle back and get some of that advantage back by adding some of that type support.
Yeah, people are learning from newer languages, which is good, I think. Usually it's that you learn from the past. Now it seems like people are learning from the future and then going back and upgrading the past, which happens, but not as much as often, I think.
Yeah.
It's the other way around.
It is really interesting. Sort of like how new languages that come out today typically come with package registries and some way to manage dependencies.
Yeah, that was the one thing that turned me off a lot about Go. I saw that you said you're working with Go, right?
I am. That's my job right now. I actually just got transferred to a team last December that manages a bunch of Go libraries internally here at GitHub.
Like when I did Go many years ago, it must have been over 5 years ago by now, I think. It was just a long time ago. Go was still quite new-ish. What I liked a lot about it was when it came from Ruby to Go, it's like night and day for speed. Testing was pretty okay. I love that I could just, on my Mac, I could just compile a Windows binary and Linux binary, I believe, when I remember this. But the bad part, like a couple of bad things. One is like I spent my whole entire day going from string to byte array to string, which I thought was ridiculous. And then the other thing too was the dependency management. So I joined this team and these guys have been working for quite some time. And you never really update your dependencies. For me, I'm a little bit more religious about that. I try to do it more often than other people. But these guys never really did that. And so when I joined a team, you do go git. And if you're pointed to a GitHub repository, you're just going to get the latest commit. These guys were like a year before or something. And so when it came time for me to join a team, like they had to update a lot of stuff in their code because apparently some of the dependencies they chose changed their interface. And so it took a while for me to even do anything because like basically I caused problems to the team because I joined a team. And when you do go git at this time, there was no package manager when Go came out. It was just go git and you get the stuff. And if you don't go get an update or whatever the command is to update your dependency to the latest one, you're just in a world of pain when it comes to like my situation. So that was a huge turnoff. And at this time, it's like we had Node, I think. We had other things. I came from Ruby. We had gemfile.lock. Why did this never happen? I guess it's because at Google, they're always just go getting the latest stuff. And so it never really became an issue.
Yeah, I think you hit the nail on the head. I think the fundamental reason that they were so late with all the package stuff was Go was written at Google, by Google, for Google, and they didn't need it because they dealt with a monorepo. But then again, I'm no Go expert, so that's just my view of it.
How was your time working with Go then, when you were working a lot with Rust in your free time?
It's been really interesting. So I've functionally, like if you take out the holidays, I've only been on the team about 5-6 weeks. So I've read a couple Go books. I'm a newbie to Go. I dabbled with it, played around with it a little bit in the past, but I'd never worked with it until I arrived at this team. So I've read a couple books. It's fun. working at GitHub, rubbing shoulders with, there are some of the authors of some of these books there working at GitHub. So there's very, very experienced Go people that I can ask questions. And that's really nice. Go is a very interesting language. Is it my favorite language? No, that's Rust. But it's not my least favorite language either. Like, it's got a lot of good things I like about it. It compiles super fast. It is strongly typed. 1.18 is getting generics. I joined at a nice time where I'm using Go 1.17, where the package handling and the module system seems to have been ironed out so that most of the sharp edges are now taken care of, not all of them. Major version numbers still require you to change your identifier for your package. That I understand why they did that. That's for backwards compatibility, but that's just a sharp edge. I don't want to do that if I change a major version number. But yeah, like, it's an interesting language. It's one of the things I like and don't like about it is it's so small in surface area, right? It's such a small language conceptually. The nice thing about that is, I mean, I read 2 whole books in the time I've been on this team, and they both covered, the entire language. And so I got 2 different views of it, and that's nice. Whereas, 2 books put together are the size of, one of my Rust books, one of the Rust O'Reilly book. But also, it's a very small language. That missing generics, hopefully that looks like it's going to be pretty nice in 1.18. So I'm looking forward to that. But I'm always just missing enums. Why don't you have real enums like Rust or algebraic data types like Haskell?
What I do see a lot of articles online is like talking about either the GC kind of messing up their day or actually how to tune the GC so that you have a better time in production. Like, do you ever have any issues with GC?
In my limited experience with it, no. I've heard, because Go's used a lot at GitHub, and I've been at GitHub for several years, I've heard a lot how it's improved a lot over the years. So my feeling is that they're in a pretty good spot now, and I don't anticipate a lot of problems with it. But again, I'm pretty new.
So do you ever say, hey, if we did this in Rust, this problem would be solved, or this would be a lot easier?
I learned a few years ago not to do things like that very much because it tends to get people irritated with you. I'm not shy about Rust, but I'm no longer pushy about Rust. So if people bring it up, I'm happy to talk about Rust. I'll talk their ear off about Rust, but I don't do the snarky comments, except for in rare circumstances when I'm really frustrated.
I tend to do snarky comments when we keep getting into the same issue over and over and over again. I'm just like, listen, let's do something else. Like, I remember working at a bank and they're like, we kept getting into the same problem all the time. And I was like, can we just try something different? And I kept getting the reply back, no, in the bank, we always do it like this. So we have to do it like this. And I'm like, then we're just going to be the same problem next month and the month after that. No, we're going to solve it this time. Trust me. Yeah, okay, whatever. So that's the same.
Yeah, that could definitely be frustrating. I hear you. The nice thing about GitHub is they are very willing to try new things. On my team, the whole purpose of the team is to support Go at GitHub. So that's not really a great place to make those kind of comments. But there are other teams and other places where it does make sense to evaluate it. And there actually have been some other teams at GitHub that have evaluated, have chosen to use Rust. So there is a little bit of Rust for some things on some teams at GitHub, but it's definitely not very prevalent.
You're not interested to maybe switch teams and get into that team so you're doing more Rust on your daily work?
Oh, it's always an option. We'll see what the future holds.
Okay. All right. I don't think I have anything else. Is there any kind of announcements or anything you wanted to make before we have the last few questions for you?
Announcements. I suppose if any of my students are listening, thank you for listening. You are what makes teaching courses worth it, like your experiences. And I'm so sorry that I have not put out any recordings or updated my latest course in the last 6 weeks. Me and my family, we've been sick. And in fact, if you can hear my throat a little bit right now, even now, it's not all the way there. I've been waiting for my throat to recover before I continue recording and finishing my latest course and my course updates. So yeah, that'd be my only announcement is sorry it's taking so long. It's health reasons. We'll finish it soon.
No shout outs or anything, like any calls to action for anything?
Oh, I'd say learn Rust. Learn Rust, everybody. It's a great language. I mean, it's useful in so many places and it's just a good experience to use. So definitely learn Rust. It doesn't have to be my course. Go pick up one of the books, go just play around with it, follow one of those online tutorials that people blog about. It's all good. It's all good.
Okay, so I think I have just one last question, which is, do you have any tips or tricks for beginners, or maybe some kind of warning what they should stay away from?
Oh, absolutely. Number one is just clone it. Just clone it. As a beginner, you really shouldn't have to deal with lifetime annotations. If the compiler is telling you, add angle bracket tick A to your struct definition, okay, don't put a reference in your struct definition. Just clone something and put it in there. That's the biggest mistake I see is people thinking, okay, I need to have my best performance, so I'll use references for everything. So I never copy anything, I never clone anything, and they just get tied up in knots trying to deal with these crazy lifetimes that they then have to satisfy, which often aren't possible. And so just clone it. Like just use an owned string instead of a borrowed string slice in your struct. And it's going to be okay. It'll still be super fast, especially if you're coming from Python or JavaScript or something. It's going to be 10 times faster, even if you clone it. So, like, it's not a concern. Just clone it. So, yeah, that would be my biggest advice for beginners. Also, it's not that scary. Like, Rust is not scary. Like, it can be super fun. If you hit a wall, come take my course. Like, it'll 3 hours. It'll just run you through the hard part, 3 hours.
Yeah, there is. I mean, the syntax is kind of scary if you're coming from, dynamic languages. And also, there is a lot of traits you have to pick up, and there's a lot of things that you run into. But yeah, I think once you work your way through those hurdles, and it's extremely rewarding.
I thought I was going to hate semicolons. And to my surprise, I didn't really. If I ever forget them, the compiler literally just says, put a semicolon right here. It's a lot better than my experience with the C languages.
Is it the Greek question mark that looks similar to the semicolon? Have you seen this before?
No, what is this Greek question mark you speak of?
I think there's some Greek character that looks so similar to semicolon, if I remember correctly. And Rust is one of the few languages that can actually notice that and tell you, this is what you put, but this is probably what you want.
Oh, interesting.
So, because there was always this joke like, hey, put is your friend using JavaScript or Java? Just put this character in there. Just copy and paste and put it in there and watch them go crazy because
And they'll never be able to find it.
yeah, because the computer obviously knows the difference, but you cannot see the difference.
Oh, my goodness. That's a terrible prank. Good thing the Rust compiler protects you from that.
Exactly. And actually, like I said, it actually says it. And I think that it not just show you the character, because even if you see it, like I said, you wouldn't be able to notice it, but I think it says Greek question mark. So you can definitely figure this out right away. So for any Greek listeners out there, be careful with your characters. Anyways, thank you so much for coming on. I really appreciate it. It was good to hear more about, Rusty Engine. What is it? Why would I want to learn it? And also more about, your courses. And it may be useful for people. I hope that we have beginners on this podcast who are getting expired and they can come check out your course because they're probably also getting trained out by the same monotonous examples and maybe want to try something different.
Yeah, absolutely. I focus my courses on being fast and fun. So it's a great place to come. And thank you so much for having me on here. This has been a blast. I really love talking about Rust.
Yeah, thanks. Maybe we'll have you back on after you kind of maybe make some more updates or something. Who knows? But just don't be afraid to reach out in case you have something you want to kind of blast out to people.
Sure, I'd love to.
All right, thanks.